All right, so in this lesson, we are going to be doing lesson 6.4, which is on modeling multiplying decimals by decimals. And in the past, we've already done multiplying decimals by a whole number. Now we're going to take that first step in doing decimals being multiplied by decimals. And if you're not sure what page we're on, we should be on page 397. I believe that's where we're at. Yeah, page 397. Perfect. All right, so doing this, we are going to be visually looking at this a lot more in a like a geometric, using our area model here. All right, so this first one, we are going to look at 3/10 multiplied by 7/10 using a decimal model. So they've already given us a 10 by 10 decimal model. That's this little grid here. And then we are going to be shading a rectangle that is 3/10 of a unit wide. So if I look at 3/10 of a unit wide, they've already identified this. Now wide means that we're going to go horizontally here, right? So 3/10, because this is 3 dots tall, so 3/10, 1, 2, 3, right? And now we're going to look at it, and we're going to shade a rectangle that is 7/10 units long. And that's going to be going vertically here. So if we zoom in again, 7/10. So we have 1/10. Well, let's bring that down just a hair. 1/10, 2/10, 3/10, 4, 5, 6, 7, right? And they've identified that as 7/10. So that means I'm going to shade all of this going the other direction here. So I've got 7/10. Now, you should notice that we have two colors that overlap. And this is where math and art become a beautiful combination, where yellow and blue, they form this beautiful double shaded area, which is then green that we can see here, right? So if we are comparing these two colors, well, how many of those colors are overlapped? How many of them have now shaded green? Well, we already had 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. So there are 21 hundredths, because there are 100 hundredths to make that whole figure there, but 21 hundredths of them are shaded. And the shaded region represents the area of the rectangle with a length of 7/10 unit and a width of 3/10 unit. And they're using unit because that would be like labeling something as 3 feet by 7 feet. And if we had something like that, well, if we had a square, right? Actually, let's not even make that a square. Let's make that, it'd be more of a rectangle. And if we were to write this out and say, oh, well, area equals length times width. If we had something that was 7 feet by 3 feet, obviously this is not to scale, but if we multiply that, we'd have a length of 7, right? And a width of 3. So 7 times 3 is 21 feet squared, right? We found the area of that. So that is exactly like what we just did with our decimals, is we're multiplying the length times the width, or we're multiplying the two units together. And so we get 21 hundredths. Now, here's the key thing, 0.21. So how are the equations 3 times 7 equaling 21 and 3/10 times 7/10 equaling 21/10 similar, and how are they different? Well, if we were to look at this and said 3/10 times 7/10, right? Well, that's exactly like what we were just doing just a moment before, of saying 3 times 7, right? We're going to get 21. 7 times 3 is 21. 1 down to carry the 2. 7 and 0 is 0, plus that 2 is 2. Now, I don't need to multiply by that 0 there, because it's all going to be zeros. So what we talked about before is that with our previous lesson of counting our digits to the right of the decimal, well, I see that I have 1 digit to the right of the decimal, and I have 1 digit to the right of the decimal. So when I add these together, that means I'm going to have 2 digits to the right of the decimal. So I'm going to 1, 2, move my decimal point over two spaces. So I have two digits to the right of the decimal. And I always have 0 in the ones place if I don't have any whole numbers. All right, so how are they similar? Well, they're similar because they have the same non-zero digits, which is the 21, right? I see 21 here and I see a 21 there. But how are they different? Well, it's the placement of the decimal point, right? Because on 21, the decimal point is over here to the right of the 1, but on 21 hundredths is to the left of the 2. So it gives it a different value. All right. So let's look at another one here. Let's jump down to the second example. So 4/10 times 2.4, 2 and 4/10. So again, we're going to use this model here. And so I'm going to use my yellow and I'm going to shade 4/10. Now that is meaning I'm going to shade everything down here, right? So I'm going all the way across everything. And the reason why we have 3 of them is because that 2 and 4/10 means I have a whole one here and a second one whole here. So that means I'm going to shade all of this and going up because I've got, this is one hole, this is another hole. So let's shade all of that. So this is the 1. And then if I shade in a second one, this is the 2 as our whole number. Let's shade that in. And then I have 4/10. So I've got 1, 2, 3, 4, and I'm going to shade all of these. Now I'm shading it in the other direction as I did with the yellow because now I have an overlap. Now I see that I have all of these. So that's 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Right? So this is 10, 20. So if I go, I've got these. So that means I'm going to have 40 of them here. And then I have another 40, right? So that's 80 total that have been overlapped. And then I have to count the next set. So this is 80. So 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, and 96. So that means I have 96 of these shaded. So that means, well, let's fill in our space here. So if we shaded, the yellow was 4/10 wide, and then we have the blue that we shaded as 2.4 units long. So when we do that, that means that we have 96 that are double shaded. They're, both. So 96 hundredths, so 0.96. So if we looked at a new little grid here, that means that I'm going to shade in 96 of them. So that means I've got 10, let's bring this down just a notch. So I've got all but 4. So 1, 2, 3, 4. So let's not shade in those bottom 4 on that last row. So if I were to combine all this together, I could have all of it fit into 100 or 100 grid, and I'd have 96 of them shaded. Now, if I did that just using straight math, because a good mathematician's a lazy one, I'm not wanting to draw a grid on every single one. 2.4 times 0.4, if I multiply that out, 4 and 4 is 16, 6, carry the 1. 4 and 2 is 8, plus that 1 is 9. So I have 96, and I have to look at my decimal points. I have 1 digit here. I've got 1 digit here, so that means I'm going to go 1, 2, and I'm going to have 0 point. What's going on here? There we go. 0.96 as my final answer. All right. So this is how we are looking at multiplying decimals by decimals, but having a more visual understanding of what that looks like.